Hey everybody, this is Larry. This is day 5th of the February Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem. Merge case sorted list. So I finally got a haircut as you can see, and also this is going to be my last video in New York for a little while. I'm going to the Colombian city of Medellin. I mean, you'll see it if you come to my video tomorrow or something, or the day after or whatever. So yeah, we'll see how that goes. I have to figure out my setup. I'm probably gonna try to bring my keyboard or something, but I don't know how everything's gonna set up. So we'll see. Yeah, that's pretty much what I was gonna say. We'll see. It's not that interesting. Anyway, today's problem is merge case sorted list. Okay, so you have these lists, the linked, and you have linked lists, and you're trying to merge them. So this is of course a very weird problem. It's definitely not hard per se, but that said, I mean, maybe it is. I don't know. Maybe the implementation is a little tricky, but the idea is actually pretty standard. It is literally a merge sort, like it's built for merge sort. And then the idea, and then your question may be, hey, Larry, when would we ever merge sort sorted list in real life? And that's true. You probably don't do it that often, but the thing that you would do, of course, is have let's say for example you have K hard drives, each with a sorted list, literally like gigs of data or terabytes of data now. I guess the hard drives are bigger, stuff like that, and you're trying to do them, in a effective way. Well, would be like this style is actually would be the best way because this is very memory efficient because you don't. I mean, okay, in the linked list, it's not technically true because linked lists are like, the memory and stuff allocated, they could be all over the place and randomly. But if you have like a contiguous space, then you get very good memory locality, right, with respect to these merge sorts, and that's what merge sort is used for. And so the idea here, and there are a couple of ways you can probably do it. The way that I'm doing it is with a heap, right? Because you can think about the way that I would think about it is just thinking about how to merge two sorted lists, and of course you have pointers. And you extend a little bit, right? How do you add three? Well, you keep track of three. How do you add four? Well, now you're just trying to generalize it for like, okay, what we're looking for is something that lets me get the min every time and then get the next number or something like that, right? Or next item on the sorted list. And then from that, of course, naturally, you have to do, it's just phrasing the question as, okay, now to get the min every single time, every iteration. Well, that is what a heap is very good for. So yeah, yeah, okay. Let's start doing it. I don't think that there's much to say really. It's just after that, it's an implementation problem, I believe, in that you have to keep track of stuff in a good way, but otherwise should be straightforward, maybe. So yeah, let's say n is the link of lists, and then we have heap is equal to a thing. The thing that I maybe would like to do is maybe more often is use a name tuple, but I actually don't know how to define. Well, I mean, I know I've done it before, and I know how to do it in the sense that I know how to Google for it, but I definitely do not always know how to do these things off my head because that's the thing is that I do know many languages per se, but I would have to Google it sometimes, right? And that's fine. But for an interview, you might, what I just said, you might talk about it with your interviewer, be like, hey, these are the things that I'm thinking of, etc., etc. But I'm not going to do it because in real life I would Google it, and a lot of people do. This is life of a senior engineer or tech lead is a lot of Googling, and there's no shame in that. Yeah, okay. So, but ignoring that spiel, basically what happens in Python in comparison is that, for example, I feel like sometimes I skip over this, and I apologize because sometimes I just assume this is things that everyone know, but it might not be. But let's say you have a tuple with 3 items. Let's just call it A1, B1, C1, and then let's say you have 2 items or two two tuples. What happens is that it just does a pair. How what's it called? Like something majority ordering or something like that. I don't know the. I'm blanking on the mathematical like precise term, but it just basically looks at the first item, looks at, hey, is this smaller? Okay, and then if it's not the same, then it goes to the next item. If it is the same, we go to the next item. Sorry. If it is not, then you just return the smallest, and you keep going, right? So basically, it compares tuple by tuple. And using this, the way that I very often do in competitive programming, for example, at least in Python, is to, take advantage of this thing to redefine an item in a tuple such that it is sorted by first column, if you will, and then the second column is a tiebreaker, and then third column is a tiebreaker, dot dot dot, as many as I need for tiebreaking, right? So that's basically the idea here. And heap is just an extension of that. Of instead of using it for sorting, we're using it for heaping or whatever. So that's basically the idea. And then now, now we just go through. For each of these lists, we want to get the first item. Yeah, okay. Let me think about how I want to do it. I mean, because I guess I could just like manipulate the list, but it is also very awkward. So let's actually set up a pointer to let's just say let's just say pointer, maybe like this pointer for each of these things. And in here we go pointer dot append list of I. So this basically gets the first pointer in each one. Of course appended, assuming that this is correct. And then we want to add. And Python is very weird syntax for heaps because it's not part of the standard library, so you have to use this other library. Maybe Q is standard, but it's still very awkward. I don't know. I'm not a fan of the syntax per se because everything else in Python is very easy, but or like it should just be a first class object if you ask me. But yeah, okay. So then now we return we want to get, so we care about the value of the item, and we also care about the index of the item, right? So that's all we had. Well, we're trying to get the min. Yeah, we're trying to get the min every time. So heap, at least in Python, does do a min heap by default, which is actually different from many other languages. So I don't know. So that's a fun fact in case you want to know. But yeah. And then now we go if length of heap is greater than 0. And of course we start at, the way that I always write these things, of course, is with a new head, like a sentinel head. So I call it new head, but let's go sentinel, maybe it's a little bit clearer. And then sentinel, and then you have a current at sentinel as well. And this is the node that goes before, and then we return. And then at the end we return the sentinel dot next, right? So that's basically the idea that we're going for. Okay. So then now, so now we get the min. So when we when we get the item, we get the value, and also, I'm just doing a quick list here whether I need over one space by doing these in place. I guess I could do these in place, right? Then in that case, I actually may not. Maybe this is a little bit awkward. Maybe not. Well, I definitely still need this for the sorting, but okay. Let's write it out, and then we'll see how we want to do it. And then heap pop of heap, and then we have I'm trying to figure out a variable name, but yeah, let's just call pre as pointer as you go pointer dot index, and then now what we want to do is we want to push to the heap the next item, right? So then that means p dot next dot value, and then we keep the same index, which is index. Whoops. And we don't care about, I guess we don't actually use this except for as a sort key, because what I'm trying to do is in place, which is actually, to be honest, if I'm in a competitive programming contest, I would not do it this way just because extra space is free, and just do it. I mean, linear space is mostly free most of the time, so I don't worry about it. But here I'm trying to be a little bit better for you at home. So we'll see how this goes. But it's a little bit riskier in that like I may have there's a more chance of me making a typo or a silly mistake is why I said it that way. But yeah, if p dot next is not none, then we set it to equal to this, right? So we input the next item onto the heap, keeping the same index. We also want to do something like, yeah, and I mean that part is good. In any case, we set current dot next is equal to p dot next is equal to none. Maybe a better way of writing it is current is equal to current dot next, and then current dot next is equal to none. This way we're resetting the next value here. But I have to do one more thing first. I have to set pointer of index is equal to pointer index dot next, and then I set the next to none. So this is actually, to be honest, potentially very confusing because some of these are by, if you want to call it, some of these are by reference and some of these are by value, and it's very confusing. Some of that I think one thing I would say is that I may make it look easy, or maybe I don't. Maybe you're like Larry is stumbling, so he does not make it look easy. But if you think I'm making it look easy, I would say that is because it's just years of practice and I'm able to visualize these pointers in my head. If you're worried about making sure the pointers are pointing at the right place, have a piece of paper and pencil and just draw out each variable name, and then as you shift what they point to. I think that's the idea that I would like to kind of get across. Okay, let's give it a submit, or let's give not submit a one test code. I clearly forgot about the n is equal to 0 case. So yeah, if n is equal to 0, shouldn't this have 0? Oh, I guess this is for n is equal to 1, but it has no value. Okay, I mean I guess that's true. Well, we still need this to append a none, but if it is not none, same thing that we have here, except for I guess I didn't realize that it could have 0 items, but this is why we test. Okay, so this looks good for now. I'm probably a little bit lazy to kind of write out more, so more example cases. Maybe I could do one more though. I could do one where like this, and of course on an interview I would not say that I am lazy. I would just write out more test cases, or at least talk about writing more test cases. Okay, so that was one I had concerns about. Let's give it a submit. Let's give it a go. Apparently I did this a year ago. I don't remember it, or 2 years ago, but we do remember a 676 day streak which we're going on here. Yeah, cool. Yeah, so this is going to be constant extra space because we manipulate the actual input, as you can see, and of course linear time because every node in the input will go into the output. So yeah, I'm curious how past Larry did it. Larry did it the same way, so that's kind of good. Except for I mean that's pretty good, I guess. And I call this tail. That's actually a better name, but oh, I guess in this case I just, instead of having a pointer array, I actually thought about this during this writing, but I was like, yeah, this is slightly cleaner, I think. I don't know. I guess it could have gone either way. I guess this time I also did the same thing, so cool. Except for this is before I used the Sentinel stuff, and as you can see, without Sentinel node, you have like these yuckier if statements in random places, which is why I started using it. That is the one thing that I do recommend if you're having fun. But yeah, that's all I have for this one. Let me know what you think. Yeah, again, stay good, stay healthy, to good mental health. I'll see you later. Bye bye.